In this episode, we're going to deploy a serverless .NET 6 web API to AWS using CloudFormation. Hey everyone, Wes here with Productive Dev. I hope you're doing well. In this episode, we're going to do a deep dive into some serverless .NET 6 infrastructure. We're going to build a serverless .NET 6 web API that will deploy to AWS using CloudFormation. Now, this is going to be an entirely serverless stack, meaning that in this particular case, we're going to use AWS Lambda as well as API Gateway to host our .NET 6 web API. We're going to do all of this using AWS CloudFormation. Now, one of the reasons that I really enjoy using CloudFormation is that it enables us to essentially treat our configuration as code. So we'll create a template YAML file that we'll use, which will essentially declare everything that we would like to run in AWS. This will include our Lambda function as well as any API gateway parameters that we'd like to set up. Then we'll look at how we can use the AWS Toolkit from either Rider or Visual Studio to actually apply this CloudFormation template using an account that we have set up, and it will essentially provision and deploy all the infrastructure that we've defined. We'll also look at how easy it is to deploy new code as we extend our API and add features. And in a follow-up video, we're going to look at how we can extend our architecture to use DynamoDB as a backing store. So I'm super excited to dive in here, and I'm really looking forward to doing more .NET on AWS. So with that, let's take a look at how we can set up our serverless .NET 6 web API on AWS using CloudFormation. Okay, so to kick things off, I'm in a new project directory here called Serverless Temps, and we can see that it's an empty directory. The first thing that I'm going to do is create a new solution file with the .NET CLI, and for that we run the command .NET new SLN. We can see that creates a new SLN file for us. So this is a .NET solution, and we're going to create a new .NET project and associate it with this solution. And we're going to use a project template. So for that, we're going to use an Amazon Lambda template, and we can install that for our .NET CLI using the command .NET new -i amazon.lambda.templates. So we can see a number of different templates that have been installed for us, including a few different tutorials, which is kind of nice, for various languages, both C# and F#, and using a variety of different AWS tooling. So we see things in here like S3, SNS, SQS, and even things like Kinesis and Kinesis Firehose. So this is a really nice collection of templates that we can use. In our case, we're going to be using the Lambda ASP .NET Core Web API, but we can see that all these other templates actually get installed for us as well. The other thing that we need to make sure we have installed is the .NET AWS CLI tool, and so for that we can run the command .NET tool install -g amazon.lambda.tools. And if it's already installed, then we'll see the message here for that. We also want to make sure that we have the AWS CLI installed on our machine. For that, we can check using the command AWS, which is the name of the CLI, and then --version to see what version we're running. We also want to ensure that SAM is installed, and for that we can run the program SAM --version, and we can see here that I have the SAM CLI version 1.53.0 on my machine now. Finally, we want to make sure that we also have an AWS profile set up. For this is going to be in typically relative to your home directory in a .aws/credentials file. We can see that I have a single default profile set up. We're going to have an access key here and a secret access key. If you haven't set up an AWS profile before, I'll put a link in the description as to how to get everything set up for that as well. So with all that set up, we're going to go ahead and create our new serverless web API project. So for that, we can run the command .NET new serverless.asp .NET Core web API. And we can see that it's actually scaffolded out a few directories here, a source directory and a test directory. If we take a look at what's in source, we have a serverless temps directory, and in here we can see our csproj file. So we can actually associate this with the solution if we like. So I'm going to go up a few directories here, back into the root directory where the serverless SLN file is. And here we can say .NET SLN add, and then I'm going to do a glob pattern here for csproj files. This is going to recursively look through the subdirectories here, and you can see that it finds our serverless temp csproj project as well as the test project and added them to the solution. So now I'm going to jump over into an IDE, and in this case I'm going to be using Rider, and we'll open the solution file to see both of our projects. Okay, so here under the source directory we have our serverless temps csproj file, and we can see that what's happened is we have been provided with a controllers directory. It contains this values controller class that we can see is just doing some very basic sort of mock behavior. We have a get endpoint, a few get endpoints, a post endpoint, a put and delete endpoint each, and it's just returning dummy data, but we can see that it is some scaffolding that's provided out for us. We also have two entry point files, a Lambda entry point, which we won't worry about for now, and a local entry point. The local entry point probably looks familiar if you've ever created a new .NET project from scratch. We can see that this is where the static void main method is. This is the actual typical entry point for our .NET application. We also have a startup.cs file, and we can see that it's also a very standard .NET 6 startup file. Here's where we can set up things like our HTTP middleware, and we can also set up things like our dependency injection. In addition to the source directory, we also have a test subdirectory where we have some tests, namely a values controller test here, and it looks like that it's set up using XUnit, which is nice. This video won't cover testing in particular, but it's nice to know that when we scaffold this project out, we also get a test project with it. So I'm going to go ahead and close this for now, and we'll minimize the test project. And the first thing that I'd like to do is to take a look at this serverless.template file that we have. Now, this is essentially a JSON file that defines a CloudFormation stack. CloudFormation stack is just a collection of resources that are provisioned and managed under a sort of single CloudFormation template file that we have here. We can see a number of different resources that are set up, including AWS Serverless functions. This is essentially a Lambda. Here we can define various aspects of the execution of the Lambda, as well as things like the size and the timeout and other values like that, and the runtime, which of course in our case is .NET 6. We can see the events that are associated with that Lambda, and we also have a section here for outputs. Now, what I'm going to do is I'm actually going to define this using YAML, and I find that for the particular use case that I'm using here with the AWS Toolkit in Rider at the time of this recording, that it seems to work better with YAML. And I should note that if you don't have the tooling for AWS Toolkit, we can get that under Rider Preferences, and then under Plugins, just search for AWS Toolkit, and you'll see that I have the toolkit installed here on my machine. Once it is installed, in the bottom right-hand corner, you can also see the various credentials that you have access to. And so the plugin is going to search for those credentials in that .aws/credentials file that we looked at earlier. There we can also define the region that we'd like to run our infrastructure in. Another note, if you don't see syntax highlighting on this serverless.template file, that can be changed in Rider, again under Preferences. Now, if for some reason you're not getting syntax highlighting here on the scaffolded serverless.template file, we can actually set that up if you hit Command comma or go into JetBrains Rider and then Preferences, and then head into Editor, and then under File Types, if we can then scroll down to JSON, and then to this we can add a wildcard.template, which I've already added in my case, and then we at least get some relatively nice syntax highlighting for this file. Now that said, I am instead going to make a YAML file for the definition because I think it works better currently with the Rider tooling. Let me know in the comments if you're doing this in Visual Studio with the AWS Toolkit in Visual Studio, and if it seems to work fine for you with either the JSON or the YAML format. For this, one thing that we can do is we can actually just copy this JSON and then paste it into a JSON to YAML to converter online. And once we do that, we'll have a YAML file. So what I'm going to do is create a new item. So we'll do a new file here, and I'm going to call this template.yaml. And I'm just going to copy this file that we have, and I'm going to paste this into a JSON to YAML converter, and then just go ahead and grab this, copy it. We can close this for now, and we're going to paste it into our template. Okay, so we should have a pretty simple YAML file here. We can see some fairly standard properties here, including the AWS template format version and a description of our application. We have empty parameters and conditions for now. Those may be useful in the future, but in our case, we have a very simple CloudFormation template to create a very minimal stack that includes a single resource here called an ASP.NET Core function. That's the name of this resource that we've given it. It's going to be a type AWS Serverless function, so essentially we're working with a Lambda here, and it has a number of different properties. First of all, it has a handler, which we can see in points to our serverless temps Lambda entry point function handler async function. We can see that here if we take a look at the Lambda entry point file and then our function handler. We can see that if we take a look in our Lambda entry point C# file, and we can see that this particular class extends this Amazon Lambda ASP.NET Core Server API Gateway Proxy function. This is the class, the base class, which is the actual Lambda function entry point, as the documentation points out to us here. So this is essentially how our application is going to be invoked when it comes to being executed by Lambda. And we can see that it's using our startup file. And in a sense, this looks very similar to our local entry point where we have this iHost builder instance when this application might be running as a hosted, actually a hosted service on a server that we've provisioned somewhere. So this special Lambda entry point is essentially pointed out as the particular handler that's invoked for our Lambda function. We also define the runtime, which of course is .NET 6, and we can configure other aspects of the Lambda, like the memory limits and the particular timeout that we'd like to have for it. We can probably bump this down quite a bit, let's say to 10, and the policies that are required. And then we have an event here under the events directive proxy resource type API with this path. So this /proxy plus is essentially a greedy path variable. So basically this means in API gateway terms that when this gets deployed as an API gateway endpoint, it's going to greedily match any sort of child route to this particular path, which is the root path /. We can take a look at that a bit later when we look at the API gateway resource that's provisioned in this particular stack. And the method any means that it's going to, this particular path is going to respond to any HTTP method. So for example, get, post, put, delete, options, that type of thing. The root resource itself is the root path, which as well is defined to respond to any HTTP method. We'll take a look at how this maps, if you will, to the resources that are created in the AWS console when our stack is created. We can also see an output here, which is the API endpoint for the prod environment. This has some string interpolation here. It's going to interpolate our serverless REST API location. So we'll have a URL here at executeapi.region.amazonaws.com/prod. So this will be the root URL of the API that we'll be able to create here. And we'll be able to create multiple endpoints. Again, we'll take a look at how that works. We're just going to develop our controller as we would with any .NET 6 API that we might host ourselves. So let's go ahead and deploy what we have here. What we're going to do is right-click on template.yaml, and then we're going to select Deploy Serverless Application here. We can see that we have a window that pops up that's going to enable us to create a stack here. So let's call this .NET Temperature API, and we can provide a new AWS bucket if we want, which is required for our CloudFormation stack. So we'll call it .NET Temperature API. And we'll leave all the other options the same, except for we'll click Require Confirmation before deploying. So let's go ahead and deploy our stack. We can see that this is going to happen in a new pane here that pops up, which gives us a build output. Okay, so just before we kick off the deployment, it's going to ask us if we would like to continue. We'll go ahead and continue. And once we've initiated the deployment, we're going to see the states of the various pieces of our CloudFormation stack move from sort of in progress or create state to a review state to a completed state. If at any point anything errors, CloudFormation is then going to try and roll back the stack so that we deprovision any architecture, any infrastructure rather, that we have deployed. Okay, so once it's complete, we should see a success message here that says .NET Temperature API create complete. If we take a look here at the logs, the event logs, we can see a sort of timeline of what's happened, as well as whether or not the particular pieces completed successfully, and we can see that in our case, everything looks like it completed successfully. And then if we take a look over at the outputs, we should have our API URL. So I'm going to go ahead and just copy this, and we'll drop it into a new browser window. Okay, so at our URL, we're now getting a welcome message. Welcome to running ASP.NET Core on AWS Lambda. Let's look at exactly where that's set up in our code. So if we come back to the code itself, we can now minimize the AWS Toolkit window. And let's take a look at our startup class. So we can see that if we scroll down to this app.useEndpoints, we have this callback function, which is mapping a GET request to the root URL, returning this response asynchronously, welcome to running ASP.NET Core on AWS Lambda. That's great. We can also see that we've mapped our controller classes, or should have, and so let's take a look at how that's set up. We have this values controller, which we see should be defined at API/controller, so in this case /values. And if we just make a GET request to API/values, we should get back this string array of value 1 and value 2. So let's give that a shot. And indeed, that's what we see coming back on the response, value 1 and value 2. So actually it's pretty exciting how quickly with this template we can deploy something. This is a live endpoint that's been deployed to the web, and it's being handled by a combination of Amazon API Gateway along with a Lambda function. That's actually quite a bit of infrastructure to be able to deploy relatively quickly. You can see that this was handled from beginning to end really with some very basic tooling. And in addition to that, we have a template file that we can now manage as code by checking this into version control. And if we need to make changes to our infrastructure, we can do that very easily just by modifying this file. So first of all, let's say that we wanted to reduce the memory size here from 256 to 128. All we need to do to redeploy this is to right-click here and then click Deploy Serverless Application again. Now, before we do that, I would like to extend the behavior of our API here to have it do something slightly more useful and to see how we can actually redeploy a new application on the existing stack. So in fact, what I'm going to do is I'm going to create a number of other directories in here, and we'll make a models directory and a new subdirectory here for business logic, and then a new subdirectory here for data access. And what I'd like to do is to essentially wire up an API that can log temperature data from any number of different sensors that we might deploy throughout a physical environment. And so we're going to create a serverless API that can both provide us with sensor data, both historical and up-to-date sensor data, as well as accept post requests to essentially publish new observations of temperature from various sensors. And ultimately, I'd like to store this sensor data in something like DynamoDB, which we can look at provisioning a bit later. But for now, let's build out some of the basic business logic for our API to actually handle this scenario. So under business logic, what I'm going to do is I'm going to create a new class here called temperature service. So something very simple for now. And we'll first define an interface, temperature service, that temperature service extends. And the sort of core data structure that I want to work with is some type of temperature log. And so under models here, I'm going to create a C# class called temperature log. And so this is going to be a very simple, plain old C# object. It's going to have properties for a device ID, a temperature F, so we'll be recording temperature in Fahrenheit to begin with, and an observed timestamp, which is just going to be a date time. So we'll have a string device ID, double temperature F, and then a date time property for the observed timestamp. So then in our temperature service, the interface for working with this data from a business logic perspective will basically do three things for us here. So we're going to be able to log the current temperature, we're going to be able to get the latest temperature, and we're going to be able to get a history of temperature, in other words, some number of observations in the past. And we'll probably extend this logic over time to get temperature from particular devices, to log temperature coming in from particular devices. For now, we're going to keep the interface really simple and we'll extend it as necessary. So now we'll need to actually implement a temperature service. So we'll implement these three methods. I'm going to go ahead and put a logger in here. And then I'm going to create a simple constructor to set that backing field for the logger. Now we're going to put our own sort of mock functions in here to set things up. So we'll have this async log current temperature, currently just log out that we're observing the temperature, and I'll just return a Boolean here. Ultimately, we will actually be logging this to a DynamoDB database, but first we just want to get it wired up as a simple serverless API without a backing store. Then to get latest temperature, we're going to put some mock data in here using a random number generator. So this is just going to get a random number between two doubles. So we have this random number between method. We'll make this async, even though we don't have really anything to run asynchronously yet. Again, logging out the random number, the random temperature between 68 and 74, and then return that rounded to 2 decimals. And then finally, we'll put a mock method in here for getting some temperature history. So for this, we have a basic for loop that is going to return to us up to some number of observations. And maybe we'll limit this just for the sake of keeping this relatively safe for now. So we'll return a maximum of 1,000. We'll call this max limit. And we'll do the minimum of either num observations or max limit. And we can make this a constant. Okay, so this is essentially going to add to a list of temperature logs a new temperature log with device ID of a string 1, and then the temperature, and then the current time. Okay, so we have a very basic temperature service set up here. So now what we're going to do is head into our controllers directory and add a new temperature controller class. We're going to give it the standard controller route here. This is going to extend controller base. This will have a logger as well as a backing field for our temperature service that we can inject in the controller constructor. So we can see that we're injecting the logger as well as the temperature service here and setting those backing fields accordingly. And we'll have a number of our own endpoints here. We'll have a get endpoint, which is going to return the result from get latest temperature. We'll have another get endpoint to return the history of some number of observations. This invokes the temperature service get temperature history, which currently is a random number generator. And then we'll have a post endpoint for recording new observations. We don't have really any query validation going on here. We're just getting the minimal amount kind of set up to explore this idea. So we're going to call double.parse. This would obviously throw an exception if for some reason we posted an observation that was not parsable as a double. And we're going to invoke temperature service log current temperature. We're going to improve the query handling and the objects that we actually post and use to fetch from our API a bit later. Again, just setting up sort of the minimal necessary to get something to play with here. So now if we head back into startup.cs, we need to make sure that we inject our new service. So just under the call to add controllers, under configure services, we're going to call services.addScoped temperature service. Okay, with that, let's go ahead and build our project. So our build succeeded. Let's go ahead and deploy to AWS again by right-clicking on our template.yaml, clicking deploy serverless application, and we're going to select update stack this time. So we'll go ahead and deploy. This will bring up the AWS Toolkit window again, and we'll wait for just a few seconds while our stack is updated. Okay, we'll confirm by continuing the deployment. And we'll get our API URL back. Let's go ahead and copy this and head back to a browser window. We actually have the same URL here, so I'm going to do API/temperature this time. And we can see that we get a value for temperature back. If we refresh, this number should change to be some random number. So we can confirm that our code is now deployed. If we wanted to get some history of temperatures, let's put a value like 10 in here. We can now see we get an array of 10 random temperatures back between those bounds that we specified earlier. Finally, let's head over to the AWS console to look at the resources that we provisioned throughout this process. To look at the Lambda section of the console, and we can see here that I've deployed two, but in our case, we have a .NET temperature API Lambda function that's set up. And we can see that it has a trigger from an API gateway. So the definition for the Lambda was specified in our CloudFormation template. And by using the IDE tooling in this case, it zipped up and uploaded our source code to AWS such that it can be deployed on a Lambda. And we can see that the editor currently doesn't support the .NET 6 runtime, but that's fine. We didn't need to upload it manually. We can work on the code, again, in our IDE as we normally do. And as we like to make deployments, we can deploy them to this serverless environment. Under API Gateway, we can see that we have a few endpoints here set up. We have this greedy endpoint as well as the root URL. So we can take a look at the details for either of these. This is a REST API Gateway endpoint. We can actually head over to the API Gateway console to see how this is set up. We have a method request set up with no auth currently set up that has a Lambda proxy integration wired up. We can see that it's invoking our Lambda function here, responding to any HTTP request that comes in, so any HTTP verb. Head back to method execution, And we can see that in this sort of HTTP request pipeline, we are invoking this .NET temperature API function. And we can get brought back here to take a look at that. If we want to take a look at the stacks, we can go into CloudFormation. And here you can see a stack that I created earlier, as well as the stack that we created throughout this video. This has sort of a GUI here for our stack information, the events that have occurred, the resources that we've provisioned, the outputs and parameters, and then the template itself, which we can see here as well. Note that we can also delete our stacks from this particular user interface as well. We can also delete the stacks directly from within Rider. So if we head over to our AWS Toolkit and we look under CloudFormation, we can select any of the stacks that we've created here and we can delete them. So we can click delete and we get a confirmation here, just like we would, or something very similar in the AWS console. And that will take just a moment. You can see that I've invoked this from the IDE. And it's a bit crowded here because I'd like to make the font size readable. You can see that we're getting delete complete for all the various resources that were provisioned. Once that's complete, if we head back to the web browser, we can see that that particular stack actually no longer exists. And if you don't see that it's been deleted, we can refresh and it should disappear. So if you'd like to ensure that you spin down any resources that you're not using throughout this particular video series, then be sure to delete using either your IDE or directly here from the AWS console. Okay, so that's it for this video. Thanks for watching. In the next video, we're going to look at how to actually provision a DynamoDB database to serve as a backing store for our temperature data.